Hello class. In this video I'm gonna show you some of the dataset that included in our application Weka and how you can run Weka and run files or dataset in Weka, and then examining Weka briefly. However, we're gonna go into each part of Weka according to the chapters that we are covering. So we might explore some of the information that you didn't see it before. However, just to give you some sense of the application before we are going more in theoretical concept. And I would like to mention here, most of the projects that I'm going to ask you to do will be based on the application. Of course, if you don't go back to the theoretical aspect and read the chapter, you will not be able exactly to know which tool you're going to use inside Weka or which option. So the reading is helpful. However, the project that you're going to deliver is based on the applications. So don't worry about learning the algorithm, the equations, but read them. It's really good to have them in your background when you are applying the data mining algorithm. You will understand it more. So for those of you who still didn't look at the Weka software from the Google search engine, you just write Weka software and go to the download. From the download, go to the developer version, and of course you can download the standalone, the binary version, but I would like you to explore more the developer version so you can see the open source code in it, and maybe some of you will be interested in extending Weka and adding his own or her own algorithm on top of it as part of one of the projects that I'm going to ask you. I will not make it demanding. I will give you another option, of course, for those of you who doesn't like to program. So pay attention to which version you're going to download. After you download Weka, you will see that it will be under your hard disk, exactly under the program files. Even that I have the 64-bit, I noticed that it goes to the program files, and I picked the 86 version, so it goes there. Now to run it, either you can go to the folder and run it from the folder directly, or of course after you download it you can just search for Weka and just run it. Okay, as you notice, it opened the command line a little bit and then it goes. Here it asks you if you want to install some additional packages. Sometimes it's useful to install some additional schemas, and so we'll run some packages. In our case, we really don't need that one. Now, what we're going to use at the beginning of this unit is the Explorer section. So just click on the Explorer. So you want to click, and always remember that the right side of the gritty video can be expanded by double clicking. Don't stick yourself by looking at a small window. Maximize it always to see the screen clearly. Now what we're gonna do, the interface allow you to do many different data mining and algorithm. As you can see, some of them are not highlighted. For example, the classification algorithm, clustering. Okay, classification is the examples that for example, the yes or no class that we looked at when we talked about cheating in taxes. Clustering, when we wanted to cluster data that looks similar to each other, and we got the algorithm how you can use the k-nearest neighbor to cluster. We're going to look at those again and again until we understand them. Association rules, here you can use it for something similar to market basket analysis. When you go to Walmart and you say, if I purchase some milk with the bread, most likely the people will purchase also beer. So that's association. You can select some of the attribute, not the whole attribute in your data set. And the most important part, which is the visualization, which is the most important part in this video, is to concentrate on visualization to understand how you can read visual data. Okay, to start our example, let us open one of the data set. The data set is included in the same path that Weka is, which is under the program file. And those of you that is using Mac, and I got one request about just knowing where the Weka located. It seems it's created as another device, and you can find it directly under this device, the data set that we are looking at. So in the program file, go to Weka, okay, and you have the folder data. You have multiple files here, and as you can see, the extension of the file is unique, is ARFF. This is a specific type of attribute that Weka support. However, if you have data set that an Excel file, you can convert the file to be accepted in Weka. So we don't really have to search all the data set that exists in that type. We can accept different types, and we're going to learn how we can import those types of different data sets to Weka. Let us first start just analyzing very simple data that you have it on your chapter 3. It talks a lot about the iris data. And more specifically, if I want to go, so you can follow with me with your printout of chapter 3, you can see your data set start from page 98. It talks a little bit about the summary of the statistics. So we can follow this visually with this application so you can understand more. So first of all, let me open the data. So this is the iris data. So the iris data, as you can see, it consists of a couple of attributes. Actually, you can really look at the data set and understand what it contains by clicking on edit. So let us click on edit, and let me maximize this one so you can see it better. In your book, it says that the iris data it contain, okay. As you can see, I had a Java error, memory error, which is, it says out of memory. So if you got this error, I'm glad I got it, you will see a document in Blackboard talking about how you can set your memory in Weka to be able to run it, to have maximum heaps memory. Okay. So let us close that application. Okay, because I was running more than one application, so it took the whole memory. But those of you who already their computer doesn't have a high capacity of memory, they can run Weka from the command line with bigger heap memory. Okay, okay, so we are opening our file, and as we said, it is in my computer, so I'm repeating. Now I think you memorized exactly where is Weka. Okay. Open it again. Weka. Take it slowly, so because it's all the folder is what, so iris. Okay, and let us edit this data. So as you can see, we have 4 attributes. The first one is the sepal length, sepal width, the petal length, and the petal width, and the last one is the class itself. So what that means? We have about 150 row, which is, that means we have 150 flowers collected, and those flowers are divided into different category, like different type, like they are similar flower but not exactly. They are iris, but there is distinguish between iris versicolor, iris virginica, and iris setosa. So what we have here, we have 3 types of flowers, and based on those attributes, which is numerical attributes, all of them, either the length of the sepal and the width of the sepal and the length of the petal and the width of the petal, it falls into one of those categories. So the whole idea, just let's go back and back up a little bit to understand why would I care if the petal width is 0.2 and why this data is important for me. In data mining, always is important to find a pattern. And when you find a pattern in data, it will be very easy for you in future. If you see a similar data, you will say, this data belongs to that pattern. In our case here, we have 3 types of flowers, and how we can distinguish if I got a new flower, where to put this flower. Is this flower is Iris setosa? Is this flower is Iris versicolor? Or is this flower is Iris virginica? So based on the data that collected previously through this data set that I have, and running the algorithm that I have, I can predict, and here is the prediction, in future, any new data, any new flower from the iris type, which kind of a flower it is. So now we understand a little bit how the data will look and how we can interpret the data. And this is kind of classified type of data set, or we can say supervised data. So we have to distinguish between supervised and unsupervised. The meaning of supervised, that already we have a class, we know the class of this data. Unsupervised, that means we don't have this class and we can invent our own class based on the pattern that we can distinguish in the data. So let me close the data now and try to analyze how Weka will look at this data. So first of all, as you can see, we have 4 attributes and a class. Automatically Weka can give you a visualization. Let me say I would like to visualize all the data. Just by clicking on this button, you will see that, okay, what I have here, which is the easiest one, I will start from here. I have 3 classes, and we saw this, we have 3 types of iris data, and this is the iris virginica. If you hover on top of the bin, you can see the type, and we have 50 sample. Now the red one, which is iris versicolor, we have 50 samples or data, and if we are at the blue one, we have 50 iris setosa. So we have 3 types of data, and they are equivalently distributed. Like I don't have a data set of iris virginica 40, then I have this one 30, and here we have 100. Then my analysis, I need to normalize it in that case and make it having the same frequency of item. Okay. Now, as you can see, the data is mixed with each other. Like there is no dramatic cut that can help me. The only one that really can help is this data here, as you can see, and which is the petal length. So as you can see, the petal length, if the petal length is the start from 1 until 2.18, so measured with millimeters maybe or centimeters. So if it's between this category, that means this flower is from type the blue, which is, we say this is the iris setosa. So here I have a very clear cut in my data set from the beginning. If I got a new flower and I measure the petal length of the flower and it was between 1 and 2.18, automatically I will say this is a petal, this is an iris type of setosa flower. Okay, this is how we can interpret the visualization in Weka. As you can see, the other type here, there is a mix, like you can tell, like if the petal length is between 3 and between 336 almost, you can say also it is the type of the middle one, which is the iris versicolor. Also, you can say from the last one between stop from here 4.54 until the end, which is, let me maximize this, until 6.9. This is a unique type of flower. If I measure the petal length and it was from this range, this is an iris virginica. So this is another interpretation that you can consider. However, the data is I cannot rely a lot on the sepal width. You can see it's really difficult. Also, the sepal length and the width, both of them are interrelated with each other. Maybe here I can distinguish the petal width just in this dimension from 0.1 to 0.58, and this direction also from here from 1.54 to 2.02. So that's what I can see visually, that I can understand the data. What else I can do? Now, you can go to the visualization that we can provide you with, and what you really can do, as you can see, it creates a different type of visualization, and actually you can have all this maximized, so you don't have to be stuck with this small dots that shows the correlation between those, and you can update. So what Weka does for you, it create like a plot matrix for all the attributes with each other. And for example here, if I want to rely on the visualization, it takes first of all the whole sample, so 150 samples I can completely rely on. You can take less than that if you want 50% of them. Now, how can I separate those data from each other? Like, for example, if I am relying on the petal length, and you can see the petal length is very difficult because all those data are intersected with each other. You can see the blue separately, the red and light blue is interrelated with each other. Here, what I can see, also if I want, this is the relationship with the class, but if I want to go between, for example, the sepal width and the petal length, okay, so I can say only the data that start from this point, and you can hover over the point and will give you actually the data more accurately. So here we can see the X is the petal length, the Y is the petal width, and I can split this data separately, okay, and you can see the last data, the value of it. Just click on the data will tell you what is the attribute of this data, okay, very easy to distinguish each one of them. And here you see the interrelation between them. So the blue one are the iris setosa, the red and the green, you can see very easy to be distinguished in this way. However, still is not so clear for me how I can distinguish my data. I'm gonna step ahead a little bit and give you one of the ways that you can rely on, and when we go into that unit you will understand it. Just consider it like ahead information to analyze the data. Now, what else we can do? We can use some kind of to classify our data. We would like to know which one belongs to which category, like which attributes with numbers. If I measure the flower with those 4 attributes that I have, can I tell which type of flower is this flower? And this is where the statistical analysis and the data mining application like Weka can help me and tell me, okay, I can predict for you those informations. Before going into this, just to be considering what you are seeing in your actually in your book, so you can understand a little bit how you can run the statistics that it's in your book. So for example, we talked a little bit about principal components. So I went to the select attribute, and let's say that I want to see the principal component, the eigenvector and the correlation matrix. Just pick this one and say yes. Okay, and I will start. So this is so that's why I told you, don't rely on the equations, just understand the equation, but from here the application will give you the result automatically. So it can create the correlation matrix for you, and it can create the eigenvalue, and it can go from high dimension to lower dimension. I will give you the vector space, the eigenvector space for you. Okay, so this is just a note here. We are not going to use it. I'm not going to ask you, but just to let you know how you can get this data. Also the cumulative, we can see it in chapter 3. I have also to create for you for the chapter 3 another video, but I decided to go ahead and show you the application so you can understand more. Now let's go to the classify. Okay, so my goal is to find a way to help me to classify my data, so in future if I got a flower, I can say, okay, this flower is Iris setosa, or no, this flower is Iris virginica, or Iris maybe also I will not fit any of the 3 category, and I will add another Iris new one because it didn't go into any of those. To be able to do this, I will say, okay, let me use this data, and we're going to talk in future about what the meaning of training set and testing set and cross-validation, but in the time being, just bear with me. Just I want to show you some of the technique to understand what you're doing. I'm going to choose something named tree, and one of those which is maybe the G48, which is very popular, and I will just say start. So what's happening here, and it was very quick because our data set is very small, only 150 row. So what happened here, the algorithm went into the whole data, the 150 row, and tried to find the best decision for me to say when this flower will be Iris setosa, or Iris versicolor, or Iris virginica. So it ran the algorithm, and it found that 50% of the data were Iris setosa based on this type of information, and I will show you what kind of information. Then it was able to classify 49 in separate way, and if you see the rest of the data 0, that means it was classified 100% right without error. Whereas here we have one error. It was able to classify it in B, but we have an error. One of this data went from Iris versicolor. This is where we saw this interaction between multiple sets. So it put it outside. The Iris virginica, 48 of them were classified right, and 2 of them were wrong. Now, if you right click on this tree, which is the most important, show me the tree that you, according to this data, that you are telling me you're able, so smart, to find the cutting edges of the tool to tell me which one is the decision that I can have to make me decide. So as you can see, what the software did, it classified all the data, and it said, if in general any flower from Iris type, I measure the petal width and I found it is bigger or equal to 0.6, I will say immediately this flower is Iris setosa. So this is the data mining algorithm, the classifier, the decision tree classifier that we picked, and we're gonna talk about it in chapter 4. So it was able to say automatically, if you are a florist and you got this flower, automatically just measure, only have to measure the petal width. If it's bigger or equal to 0.6, okay, you will say this is Iris setosa. However, if it's if it's less or equal. Now, if it is equal, if it's bigger than 0.6, you have to do another measurement. What is the other measurement? You have to measure the petal width now. Again, if the petal width is bigger than 1.7, immediately you will say it is Iris virginica. Okay? Now, if it's less than or equal to 1.7, so when it measured the petal width and it was less than 1.7, I have to do another measurement, which is the petal length now. If it's less than 4.9, automatically here again I can say it is a flower of type versicolor. But if it is bigger than 4.9, I have to measure now again the petal width. If it's less or equal to 1.5, it is virginica. If it's bigger, it is versicolor. So this is the whole idea of using the tool that by itself will look into your data and will decide for you the rules that you have to apply. So in future, if you come up with a new flower, let's say I measured the flower and the petal width was 1.2. So I will go into this tree and I will say, okay, where is bigger than 1.3? So I will go in this direction. Is it bigger than 1.7? No, it's less. So I will go in this direction. I have here to measure the petal length now. So let's say I measure the petal length and I found it is less than 4, for example. So I will say, okay, this is versicolor type of iris flower. So I hope with this very, very short video tutorial, just you got the notion of the data mining and how you can mine your data and come with analysis that will help you to decide some kind of pattern in your information. I hope that was helpful. And for the error, I got another error for Java virtual machine, and I will add, as I said, the type of information that you have, and actually it gives you the information. You can, if you read it, you apply it. That's what you have to do, and usually you have to add the path to your environment, to your Windows environment. Okay, that's enough for now, and see you in another video.